the keynote talk before the break. We make it after the break to give you time to enjoy the nice stuff that the General Chair and her team created. My name is Khalid Al-Maleh from Qualcomm San Diego. It's my great pleasure to introduce our keynote speaker, Professor Koo from University of Southern California. He's a well-known professor who always attends these conferences, so most of you maybe know him. Professor Koo is really like, I like Professor Koo for many reasons. Being from industry, I feel he's like really a mentor for all of us. He graduated like 250 PhDs, limitless, endless master, postdoc. He has 900 conference papers. He has 250 journal papers, 14 books. And the theme of the talk today is about interaction between academia and university and innovation. If you notice, we intentionally invited our keynote speaker from academia just to highlight the important point that innovation starts in academia. Why? Because all the speakers who presented from all companies and the speakers that will present after, for sure they did education and university. So as someone from industry, I deal with innovation in multimedia. I have distinguished my career by working closely with my colleagues in academia. So I'm very active in IEEE Signal Processing Society, and I participate. So that's really given me a lot of value. And the same with professors, is value for them to interact with industry. I want to invite Professor Koo to stage to talk about data-driven perceptual coding. And he will share with us his interesting insight of working with industry as he developed his research. Please join me on stage.
Thank you. So it's my great pleasure to be here. And actually, I'm the only representative from the academia world in this innovation program. So I think and actually, majority of the audience are either students or faculty, I believe that. So I think people will want to know in academia what we can do and how we differentiate ourselves and also how we can collaborate with companies. I will use just one example, data-driven perceptual coding as example, but let me talk about the different research flavor. Okay. So academia research, actually, I feel the most important thing is about ideas. Of course, you have to show it's a workable idea to a certain degree. So you may do some simulation, you may do some proof of concept, prototyping. But most important thing is idea. And industry actually pay attention to the final product, interfaces, platform to the users. Okay, so there are a lot of work need to be done to put an idea into a product, service, and so on. So you listen to many, many talks in the first session. It's all about this kind of things, the services, the product, and some relate to the business models and the platform and so on. So really, academia and the industry are positioned in different things. In terms of time horizon, industry usually talk about 1 to 3 years. Of course, those big CEOs for big companies, they may think 5 years, 10 years, but I think that they can only make a guess. They really don't know what will happen in 5 or 10 years. But they're always looking for the next billion industry sector, so where to get the next golden cow, right? But for the academia, if we only think 1 to 3 years, actually, we will have a difficult time to compete with industry. So we have to think about either a new area, industry still hasn't invested a lot of money in that, or we think something a little bit long time for a horizon and so on. So there are like a lot of deep learning things. The academia want to compete with industry, I think extremely difficult. So we need to think about our position. Then in terms of the practicality, how the idea or technology can be used, I think academia should somehow make it a little bit loose, relax that a little bit, not too much focus. And the industry, of course, you need to make something profitable. Okay, so I think that's also a very different priority. So these are the two angles to see these two. And then we look at good models. I learn a lot from industry people by talking to them about problems. Okay? They will ask me some problems, and I listen to their problem, and then I know what's the key thing in their mind. They usually seldom tell me the solution, the technology, or whatever. Most of the two-way communication is mostly mine to them, 80 to 90%. They, to me, is very little, 10%, 20%. Okay? But this 10%, 20% is very important. If I listen to them, then I know what's really important. Okay? You have to make a guess. And human resource, I think the industry people, they can pay high salary, they can use that as an incentive and other things to attract good engineers. But in university, actually, the pay is very low. I think the motivation really is the diploma, right? They get a degree, but they are highly motivated. They work very hard to achieve that goal. So, and also less constraint. There's no time constraint in some sense. Industry, the product timeline is very rigid. Okay? There's no merit review in the sense that the TARA salary will be the same no matter what you do, right? As long as you get the offer, you get the same salary. So it's a different kind of situation, and in this academic environment, allow people to think a little bit longer term, and also different cultural value. The industry, I think, as I said, one important thing is the confidentiality. When you talk to people, they usually keep a lot of things secret. They don't tell you a lot of things. Even today's talk, I have to say, most we listen to the product, service, and so on. Technology itself, maybe no time, but also they're probably not allowed to share, right? But in academia, you want to let people know what you're doing. So it's a very different kind of culture. But we can work together. We can have a sort of complementary strengths. The poor collaborative model basically just getting money from industry and become their engineer, solve some of the easy problem. So this, I think, definitely something we should avoid. Okay, I try to avoid that. I don't want my student just being a programmer for some small companies. So talk about my lab at USC. I have worked with more than 70 companies with like 250 research projects. And so actually my funding most from industry. And I have graduated 134 PhD students, around 10 master students, and so on. So majority of them are working in industry, and so on. So I know industry quite well, we're very well connected. That gives me some tremendous advantage to work with company. And now let's look about, that's a sort of more general framework. And now I pick a topic as an example to demonstrate the process. So yesterday there was a panel talk about video coding. So really video coding, still something to do, right? I think at MPEG-1 and MET2, we know it's really close collaboration with industry and academia. But after that, H.264, H.265 really were dominated by industry, the standard activities. It's really too costly for academia to participate. And also a lot of things really, it's just fine-tuning, keep fine-tuning. That's also not good for the innovation, idea innovation, okay? Now, what's the next? H.266. Will that repeat the same thing, that you fine-tune H.265? Actually, I talked to many engineers, like Samsung, Huawei, MediaTek. They lost interest, okay? They feel bored. They're really not interested. They say, maybe I can twist again, get even more modes and put the 20% or something. But they feel this is so boring, okay? So if we want to look at new direction, I think to count on academia people to think about new ideas. So here I think about perceptual video coding. Perceptual video coding actually is an old topic. It's a long-standing problem. People really don't know how to do it. Although audio coding, people use the perceptual audio coding widely. So technology well-known and used quite widely. But in video coding, somehow people don't know how to use it. Today, still no clear answer how to use it right. And a lot of companies have some small trade secret. They do pre-processing, do post-processing, and make the video look good, but they don't want to share with other people, and they really cannot compare apple and orange. So they just say, well, I have a good solution. Something look good, but I don't tell you what it is, okay? So this is like a perceptual coding, video coding status. And actually, there are two major challenges. One is about the diversity of people. So whose experience we trust? Should we trust a very small number of people called the golden eye golden eyes, or should we trust a great majority of people? It probably in the old day, people talk about broadcasting content. So in broadcasting industry, they insist quality is everything, okay? Quality is the most important item. So you cannot really sort of compromise in that. But when you talk about video streaming, the channel bandwidth is not reliable. So you really no guarantee quality. So how you insist that? So I feel due to the application, actually you will consider a new optimization problem. Another is diversity of video content. We know different kind of video content has different kind of, different bit rate. Still sometimes the cartoon, you have low bit rate, but people feel it's a good quality. And some very complex sports video, even high bit rate, people feel bad quality. So this kind of dB comparison between Apple and Orange really cannot compare. So this applies to all kinds of video quality metrics. You do PSNR, you do SSIM, you do all kinds of things. You still cannot compare different contents. Okay? Only the same content you can compare, but different content you cannot. So we need to address this kind of issue. So one is about people. And I think if you look at the people as a group, then we can take a statistical approach. We can take a big data approach. So that's more objective. And content diversity, I think there are simple content, there's a complex content. So simple content, I show here several simple content. This kind of content, actually we ask people to see, on the average, people can see 8 distortion labels, distinguished distortion label, 8. But so complex content, a lot of masking effect, there is no visual salience, and people can only see, on the average, 5 distortion labels. They cannot see more than 5. Okay, so these are the content dependent. And so how we look at this kind of content and adjust your coding. So actually also people try to do like pre-select the quality labels, say 5 quality labels from excellent, very good, good, fair to poor. But actually, you are not able to capture very useful information. Say, how many query label with this content? Because you pre-selected 5. And sometimes people choose something very bad. Actually, most of the application, you may not go to that kind of bad quality, right? So really cannot address this issue. So I visited Netflix on February 12, 2015. That's the day, actually, I started to talk to them about the JND concept. Of course, this idea in my brain sort of stayed for a while. But that's the day I really bring it out, clearly explain what I plan to do. JND actually is a psychological experiment, right? So your middle box, your environment, you want to see. If the same grayscale you cannot see, but then you change it, you can see, right? But here, the same thing. If we have the left one is called anchor, and then we can have something very poor, so we can see the difference. And here, something very, very close to anchor. You cannot see a difference. So there must be a transitional point called the just notable difference. So that's the way we apply this concept in the coding area. And then I propose them, say, you only can see a fixed quality label. So will the stereo quality function like this? This is a quality factor, right, for the JPEG. So 0 means the worst, and say 1 is the worst, and 100 is the best. So the quality going down this way. And this is the PSNR. You do the JPEG compression. So it's a smooth curve. Here I get a discrete stair function. So here basically is challenging the Shannon rate distortion theory, because Shannon says this is the distortion, this is quality, bit rate, and you go this way. But actually we show like this way. So some people ask me, what's the rate this? But actually, I think the Shannon theorem does not put the human perception into account. It's only about source and distortion, but no receiver inside. So if we have this kind of things, means actually when the distortion is very, very small, our brain just a clip. You have the cumulative error large to above the threshold, then fire. We see the difference. So really sometimes we argue 0.1 dB, 0.2 dB, and argue whose solution is better. Sometimes it's really meaningless. For most people, they cannot see the difference. So really you have to ask people to make the judgment rather than using the PSNR, the machine, to make the judgment. So we try to do this. We build a data set, 50 images, and ask third people to see that, and we have released the data. And these are the 50 images, and we encode all the image with QF, quality factor from 1 to 100. So it's 100 compressed image for each one, 100 for each one. And then we ask people to select the JND. And we try, first we use the 100 as a reference, and we choose, using bisection search, choose the one which is just different, just the visible distortion. And suppose we come here, then we fix this one as a reference and look for the second one, and so on. And for a group of people, we basically try to find the first GND for a group of people and then choose the, say, 50% or 75% location and fix that, and then search for the second one. It's group statistics. And we also work on the video. We have 30 video clips, 5 seconds, and we have different kind of frame rate. And ask 50 people to review it. The reason I want 50 people is that I really suspect JND should be follow a Gaussian distribution. So I want to see that Gaussian envelope. So the first JND and so on. So ask 50 people, and then we can show, indeed, it's really like Gaussian. If you do some, so these are 30 video sources. And these are the 3 JND points. The first JND is the lower QP, and the second one, third one. So these are the video index. And this is the JND, we choose the 75% people satisfy that. We choose that the first JND and second and so on. So we can see it's content dependent, and there are variations. But this is basically, this is the range. Most video you see from the surface. Okay, the surface, the video streaming is this kind of range. So it means 3 JND will be sufficient. And JND is a random variable. You follow the Gaussian distribution. And actually, you can use the mean and variance to model that. And then use that. For example, the first JND is a perceptual lossless, a perceptual lossy. And then you can look at the certified user ratio. And this certified user ratio can be a universal quality. It doesn't matter which sequence it is. As long as you find the first JND, you find the certified user ratio, then you can know what's the bit rate you should send. Okay, so this is talk about even different video, but use the SUR, you can start to compare things. So this just shows the example. This is the bit rate, this is the PSNR. You really don't know which one you should operate. But this is for the first JND, this bit rate, this certified user ratio. So I want to make 80% people happy. Happy means they cannot see the difference between the original and this one. They are happy. And the 20% people not happy because the JND already arrived, so they can see the difference. So I can use this kind of percentage and determine my bit rate. So this kind of value is extremely important for streaming video company. They can know which bit rate to operate. And similarly for cartoon, Foxbird, you can use a 2.6 megabit to make 85% people happy. And 3 JND, there's reason to explain. We need a 3 JND so that it will operate the typical, this is over-the-counter service, 18 to 35. The third JND is between the fair and poor already. So you don't need to go to the fourth, fifth, and so on. You can go, but it's really not the quality too bad. No one will serve that kind of video. So this kind of things means actually you have to do large-scale calibration by human subject test, okay? And then you can change the RD optimization to a first machine learning problem, use that data set, and start to predict the JND location based on the content. And the content usually we start short, like 5 seconds, and then move on. So it's a time-varying windows. So actually, I work with the NetX funding to do the 2 JND tests. One is a JPEG, one is the H.264. And then I use that to talk to a few companies and got the support from Huawei, Samsung, and MediaTek. So these 4 companies now help me to do a large subject test in Shenzhen. It's cheaper, okay? So in phase 1, we have 220 sequences, 5 resolutions from 4K, 1080p, 720p, and a quarter of 1080p, and so on. The reason is for the smartphone display and also for the tablet. So we want to try all the resolution and ask people, and we plan to collect 35 samples per sequence resolution. It's a very large-scale experiment, and it will be done in October, November. So actually, then they show the future R&D is first is using today's codec, find the human experience and predict the JNT location, and then you can predict the operating rate, the bit rate. And then next one is you study the machine learning, the feature, the prediction. Once you know that, you know what's human sensitive. And you know what's human sensitive, then you can try to erase that, right? Masking that, so people cannot see that. So the longer term mostly is try to push the first JNT away from its reference. So either smaller QF or larger QP. So you push that. So you want the stair, just like when it starts going down, it's just going down quickly. You don't want going down and go further and so on. So you don't want to prolong it. You want, if something going down, just to collapse. And try to push the first line as far as possible. So this is the way, from the academia view, I work closely with industry, but I continue to provide the idea to them, and they are very happy and very supportive. So I'm just showing, academia can do something different if we think hard and so on. So I think let's conclude my talk.
Being from industry, and actually I was leading the video quality team in our chip business, I really get to appreciate his insight from academia. And definitely have one question: what are the characteristic of the 15% who are not happy? Is there anything like age or, but we'll take it offline. Please join me in thanking him again. Thank you very much.
Thank you.